So hey nerds, this is Suman and this is our today's integral. And this integral might look some familiar to the advanced level student and might looks very much bizarre integral for those who really doesn't understand this integral. So yes, in this video I'm going to solve this integral and help you to how to evaluate the integral. So I have got some problems with my eyes, you can see from here. So it doesn't matter. Okay, just we have to do this integral. So when you look up this equation doesn't feel any substitution. We cannot substitute anything or we cannot use any other things related. But we can do a simple, really helpful expansion, like expansion of sin nx is x minus x cube over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial plus so on and on. Yes, it looks like that. So in my integral I'm going to write it like this, and I'm going to get x minus x cube over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial plus so on and on, and we have dx here, and the whole thing is divided by x. Okay, so once you divide each term you get 1, okay, minus x square over 3 factorial plus x4 over 5 factorial minus x6 over 7 factorial plus so on and you get dx. And I want to write it in the whole bunch of equation, this non-intuitive non-intuitive polynomials into my summation form, and I can write it as like this: the summation, okay, that n goes from 0 to infinity. Okay, since there are alternate positive and negative sign here, so in order to encounter that we need minus 1 raised to the n. Okay, the power actually goes on increasing from 2 in every step you jump from lower to higher, so it is going to be look like x raised to 2n over the factorial actually increases by, look like this, 1 3 5, so it actually goes like 2n plus 1 factorial, and it is going to be dx. Okay, so once you get this thing done, you can actually pull out the summation out from the integral, and goes from 0 to infinity, negative 1 raised to n over 2n plus 1 factorial out, and you just get integration of x raised to 2n with dx. So we all knew that our final expression is going to look like this. It goes from 0 to infinity, negative 1 raised to n, and the simple power rule formula for this is 2n plus 1. Okay, and we have 2n plus 1 factorial here, and we just need this term in denominator, that is 2n plus 1, and never forget our beautiful integration constant c. So this is the final integral of this expression. So you can actually do it in that way. So similarly, if you want to try some new integral, you can actually do 10x over x and with respect to dx. Up to there, bye bye.